Hello, everyone. This course we will talk something about the new dynamic routing protocol, ISIS. And about this course, we will introduce some ISIS principle. And the full name of ISIS is Intermediate System to Intermediate System. This also is a dynamic routing protocol and usually used in an intradomain. That means, for example, maybe you have one company or maybe you have one school and all the network devices can use ISIS protocol to exchange some routing information. And at the beginning, this protocol is used for the ISO organization, and it provides a service for the CLNP, Connectionless Network Protocol, because as we know, in our network, we have two reference models. One is OSI and another one is TCP/IP. But now currently, because lots of scenario, we will use a TCP/IP, right? So if we also want to use a ISIS protocol to help us get more routing information, we have to change some feature. And the new the organization IETF enhance the ISIS. So finally, the integrated ISIS can be deployed in the TCP/IP and also the OSI environment. So about this course, we have lots of topics. First, we want to know some basic introduction about the ISIS. And the second one, we want to know some principle, how to work of this protocol. And then the key point we want to use ISIS is getting lots of routing information. So in ISIS, how to finish the route calculation, and then is basic configuration, how to add the commands on the router. Then the router can run the ISIS protocol and also to get the correct routing information. And the last topic, we will provide some comparison between ISIS and OSPF, because these two protocols are the typical protocols we can deploy in our network. What are the similar and what are the difference? So there are 5 topics. First one, let's say some introduction. And about the ISIS feature, the origin for the ISIS we say is used by the ISO organization and for its CLNP network. And of course, now we talk everything for the network technology based on the TCP/IP. So if you are interested about the OSI reference model, maybe you can get more information on the internet. And now for the development of ISIS, because we also want to use this protocol in our TCP/IP organization, right? So TCP/IP reference model in the IETF organization modifies the ISIS to make the protocol to become integrated ISIS. So now we can use the ISIS in the OSI reference model and also the TCP/IP environment. So this is a basic one. And another is ISIS belongs to the IGP protocol, okay? And it also is a link state routing protocol. So if you deploy the ISIS, you also can get all the features of the link state algorithm. There is no loop, right? And you have to establish the neighbor. Then you will exchange some link state information and finally to calculate some route information. This is a similar step like the OSPF. And another feature we want to use ISIS in our network is this protocol can support flexible TLV code and has great protocol scalability. So what's the meaning of this structure? if you want to let ISIS transfer more information in your network, you can directly change the TLV architecture. So one example is for now our network usually deploys IPv4, right? And you can use ISIS to make your IPv4 network devices get all the routing information. But maybe in the future, you will deploy the IPv6. And ISIS also can directly help us to forward some IPv6 routing information. This is very good because you don't need to add other protocol. But about the OSPF, you have to deploy a new OSPF. We call it OSPF v3 to support IPv6 feature. So this is a very big and good feature. We want to use ISIS. And another one is ISIS also has faster routing convergence feature and a clear architecture. And later we will explain because in ISIS we also support divide multiple areas, and the architecture is better than OSPF to use in the larger scale network, right? So because we talk OSPF in before with the OSPF, you deploy the area, there's some limitation. You must make your backbone area continually, logical or maybe physically. So this is a limitation. But ISIS is very easy. And then let's say some basic concept of ISIS. Although ISIS is used for network devices getting more routing information, right? So maybe in your network, you have lots of router like here and connect with lots of terminals. Maybe in real network, your devices will more than here. And also you will have lots of layer 3 switches, but it doesn't matter. For example, here is a topology show for you. And if you deploy the ISIS, there's some basic concepts like you can divide the whole network to become the different routing domain. And maybe you are more familiar with the AS, right? One AS also is one routing domain. You can think in one routing domain, maybe the same organization will maintain your network, okay? And in the other company, maybe like the internet belongs to the other routing domains. And then you also have to divide the router into different area, and each area will have the area ID, like the area 1, 2, and 10, right? This one is same. And the difference is in the ISIS, one router, all the interfaces must belong to the same area. This is different with OSPF, right? So the each in the ISIS is a link. For example, here, one router must two interfaces, both of them belong to the area 1. So this is the area division. And another one is all the router in the ISIS routing protocol, we call it IS, intermediate system. And between these routers, we will run the ISIS protocol, okay? All of them we call it ISIS protocol. And all the terminals we call it ES and system. And between terminal and IS, we will run the ES to IS protocol. Maybe in the TCP/IP, this protocol is ARP protocol, okay? So this is a basic one. And the full name of the devices, IS is intermediate system in the OSI reference model. And in the TCP/IP reference model, this one we call it router, and also the layer 3 switch. ES is end system. In the TCP/IP reference model, we call it host. And ISIS is intermediate system to intermediate system. The function is very similar like OSPF. So this is a basic concept. And we call the ISIS, we also can be divided for multiple areas, right? And in these areas, we will have two type. One we also call is backbone area, and another one we call is non-backbone area. And if we want to connect different areas, for example, like the topology, we have area 1, 2, and area 10. How to connect with different area? We will use some special router. This router we call is L2 and the level 1, level 2 router. So this is a router type. We have 3 router type, level 1, level 2, level 1 and 2 router. And one router has a maximal number. You can configure 3 area IDs. And all the router interfaces must belong to the same area. This is a limitation, okay? All the interfaces must belong to the same router. But in one router, you can create more than 1 area ID, but less than 3 area ID. In which scenario you want to use multiple area ID? For example, at the beginning, one router belongs to area 10, but now because your network will become bigger or maybe smaller, you want to change the area ID to become area 20. So you can create area 10 and area 20 at the same time. Your network will not be broken. So this is a scenario. But the maximum number of the area is 3. And about the IS, we have 2 levels. One is level 1 and another one is level 2. And the level 1 is a common area. Okay, you also can think this is a non-backbone area. And in this level 1 area, we provide consisting of area level 1 routers. And if you want to establish the adjacency, because you only have the adjacency, then you can get the routing information. And the level 1 adjacency only can be established in the same area. So this is level 1. And about the level 2, you also can think this is a backbone area. And it continuously by the level 2 router. Also includes the level 1 and the level 2 router. This level 1 and level 2 router means you will have level 1 ability and also have the level 2 ability at the same time. And which do not have area registration. That means maybe you have 2 level router and they belong to different area. It don't matter. The backbone area only depends on your router type. No matter depends on your area ID. If you are the level 2 router or maybe level 1 and level 2 router, you will become the backbone area number. So this is a definition. So if you know the lead architecture and then come back to say the ISIS instructor, for example, you already have router, right? And all the router we call is IS, but now we give different level router, like this router. If your router connects with different area, this router must belong to area 2 or maybe level 1 and level 2. They can be the edge router to connect with multiple area, right? Like this router connect with area 2 device and also connect with area 1 device. And also the same with this router and this router. And another one for the router, if all the interface belong to the same area, and also you connect with the terminals, you can make the router to become level 1 router. And why you define different, definite the different level area? Because about the adjacency and also about the routing number, it will be very different. And then between different router, we will get the level 2 routing information. And in the same area between these level 1 routers, we will get the level 1 routing information. And finally, the level 2 and the level 1 and level 2 router will make to become a backbone area. Although the area number will be different, it doesn't matter. So this is the definition of the backbone area. So in this process, we will see 3 types of router, right? So the first type is a level 1 router. And about the level 1 router, if they want to establish the neighbor relationship with the other devices, we only can establish the adjacency with level 1 router in the same area. So this is a limitation. And another one is if you have multiple neighbor, we already established the level 1 neighbor relationship. And finally, you also will get the link state database, right? This is our purpose. And we only will maintain level 1 LSDB. And in the LSDB, we only have the detailed link status for the local area. It is very similar like the specific area in the OSPF. We only have the detail in my region, but how to weight the other region, how to weight the other areas, right? We will ask help to our level 1 and level 2 router. And the nearest level 1 and 2 router will stand out, will give us one default routing. Okay, will give us the default route. So we will directly to weight the other area, also the other domain by the default route. So this is a relationship in the level 1 router. So if your device's performance is not so good, you can make your router type to become level 1 router. Okay, and the special one is the level 1 and 2 will send out a default route. The special default route will give one ATT bit to become 1. And later we will explain what's the meaning. And finally, the purpose is send the level 1 router. You can go out by the default route. And another router is the level 2 router. And about the level 2 router can establish the adjacency with level 2 and also the level 1 and 2. And we don't have the limitation of the area. You can establish the adjacency in the same area or maybe in different area, it doesn't matter. And you only will have the level 2 relationship. And about your LSDB, you will maintain the level 2 LSDB. And in the level 2 LSDB, you will know everything in the whole backbone area. So you will get the detailed information. And the third type of the router is level 1 and 2 router. Because about this router, you have level 1 relationship and also have level 2 relationship. So you can establish a level 1 adjacency with level 1 router. And also you can establish the level 1 relationship with level 1 and 2 router in the same area. If you want to establish the level 1 relationship, you must belong to the same area. And also you can establish the level 2 adjacency with level 2 router and also the level 1 and level 2 router. And no area limitation. You can in the same area and also you can in different areas. And this router will have 2 LSDBs. And the level 1 LSDB is used for the routing within the area. And the level 2 LSDB is used for the routing between different areas. So you also can get the whole routing information according to the L2 LSDB. And by default, the level 1 and 2 router will redistribute the level 1 routes into the level 2. That's why the level 2 router in the backbone area, you will get everything, right? This is a function of the level 1 and 2. because level 1 and 2 router will get the level 1 information from your level 1 neighbor. And then I will directly send this information to become level 2 routes and then send to my level 2 router neighbor. So this is the default function. And if there is a large number of level 1 routes, they should be combined before them are further distributed into level 2. You can do some summary function, okay? So there are 3 types of router. It's very important, okay? And if you already know the basic concept, then we can go to the next step.